number, so more than one citizen might share a phone number?
Repeat your last sentence.
More than one citizen could share a phone number if they share a house phone or even a cell phone?
That's not an issue. That's not an issue.
Okay.
Why? Let us say, let us discuss the problem. Let us say my phone number is, I will not tell you my phone number for real. Let us say my office number, I'm just gonna make up something. 5678. All right, that's my phone number. Okay. Now, let us say me, I use this number. My son, let us say I call it Peter, for example, use that number. My husband, let me call it Tony, for example, use this number. Does this, if we have this picture, is this a function? Is this a function?
Yes, that is a function.
Now, who can argue, who can tell me something else? Why, who can argue this problem?
My only thing is that when assign numbers, when assign phone numbers from an input, there's no correlation when you actually say put them on a graph next to each other. And
we're not going to worry about graph. I'll worry about it next hour. I just now want you, we're not worrying about the graph. Are you with me?
Yeah.
I'm worrying about input and output. Can we assign to each input exactly one output? That's really my
point. Yeah, in that case, then it would be a function because each input will have one output.
Why? Why? Does every input have exactly one output? What do you think? Does every person have exactly one phone number? And you have two phone numbers. Matthew, you say no, because?
I'm saying, yeah, you can have more than one phone number.
Right, we can have more than one phone number. So if I ask, if you tell me, okay, what's your phone number? So it's me, I am, what do you want me to associate to it? Okay, if you tell me what's your phone number, I tell you, okay, which one do you want? Is it my home? Is it my cell phone? I may have two cell phones, so I may have two phone numbers. So the output for every input here is not unique. So is this a function? The answer is no, because a US citizen may have more than one phone number. It could be the home phone number, it's a cell phone number, it could be the work phone, and so on and so forth. So is this a function? No, the rule does not define a function because the inputs, which is the US citizen, can have several outputs. What are the outputs? It could be the home phone number, the cell phone number, the work number. So is this a function? And the answer is no, because every input may have, some people may only have one, I know that, but some may have more than one. So an input may have more than one phone number. It means more than one output. So therefore, this is not a function. Okay, that's the way we have to look at it, not only in a very narrow sense, in the whole sense. So this does not satisfy the main condition of a function, which is the uniqueness of the output. So there is ambiguity. So if you ask me, what is f of norma? I don't know what f of norma is, because f of norma could be any of those. So there is ambiguity in the output. So forget it, that's not a function. Okay, I'm sorry. Now, example number 2. Let f be the following rule. Let f be the rule that assign to each US citizen the name of their biological mother. Is f a function?
Yes.
Everybody agree that it is a function? Is there any ambiguity in the output? So if I take any US citizen, is there any ambiguity? What's the name of their biological mother? There is no ambiguity. because we have only one biological mother. So there is exactly one output for every input. Okay, so if I write f of, let me pick somebody we all know, let us say Malia Obama. So let f be the root assigned to f, the name of their biology. So f of Malia Obama is equal to Michelle. That totally makes sense because Malia has only one biological mom, which is Michelle. So f of Malia Obama is equal to Michelle. So that's absolutely a function because every input have only one output. We cannot have two biological moms. So that's exactly a function. So I want you to interpret the following sentence now for me. Interpret. F of Norma Elias is equal to Yvonne. I would like to interpret this sentence for me. So my function here takes a US citizen. By the way, I am a US citizen, decide my accent, and associate to it the name of the mother, the biological one. So suppose I take the sentence, f of Norma Elias equal Yvonne. How can you interpret that? Anybody? So f is the same rule. We decided it's a function because every person have only one mother, so the output is unique. So now I'm asking you to interpret this sentence for me. F of Norma Elias equal to Yvonne, and somebody, of course, did it. Means the following. Norma Elias is the input. That's the input. What does F do? To every input, F of Norma Elias represent the output. To every input, it associates the name of the biological mother. So F of Norma Elias, that's the output, should represent the name of basically my mom, which is Yvonne. So F of Norma Elias equal Yvonne means that the name of my biological mother is Yvonne. So F of Norma Elias equal to Yvonne means that the name of the biological mother of Norma Elias, biological mother of Norma Elias is Yvonne. That's how we interpret this sentence. So the input is the US, the output, which we use this notation to denote the output, is the name of the biological mother. All right. Please ask questions as we go on. Now, one more example is the following. Let F be the rule that assign to each number the number 3. So here, my input is a number, and F is a rule that assigns, so S is a rule that assigns to each number the number 3. My question is F a function? So first, let us understand what F does. F does to every number, so you give F a number, that's F. So I imagine F like a machine. You give it something, it spits out something. And F will do what? It will associate to it rule assigned to each number the number 3. Is F a function? Yes or no? Back to you.
Yeah, it's still a function because it is exactly one output still for each input.
Right, it's exactly a function. So the answer is yes. Because we have exactly one output, which is 3 for the input is changing. The input is a variable, it's changing. The input could be any number, 1, 2, 3, a half, fourth, any number. These are the input. So the exactly one output for each input. Okay. So for example, if I ask you in this particular problem, what is f of 1? What does this function do? The function assigns to each number the number 3. There is no ambiguity. You tell me 3. That's it. The whole class would tell me 3. There is no ambiguity in the output. If I tell you what is f of 100, again, no ambiguity. It's equal to 3. So it is a function. Everything goes to 3, but everything goes to one thing, exactly one, which is 3. Therefore, this is a function. No input go to the different output. We don't have that issue. But a lot of input can go to the same output. That's okay to define a function. All right. Now let us say, so f of 1 is 3, f of 100 is 3, f of anything minus a half, that's a number, is equal to 3. That's really the picture. So no matter what the input is, the output is 3. So a better way to represent this, I say, okay, if x is a symbol for a number, any number, so x now become my variable. Okay, x is a symbol. So what is f of x in my problem? Suppose x is any symbol. What is f of x in my problem?
3.
Is equal to 3. Okay, because what f does that to any number, it associates 3. So instead of telling you f of 1 is 3, f of 100 is 3, it's kind of really not an efficient way of writing the rule. So we say that if x is any symbol that represents a number, my function f of x is equal to 3. It means it associates, it assigns 3 to every number. So now I'm going to work with you on some worksheet, more problems that have to deal with function. They are a little bit different than the type of function you guys have seen back in high school, some of you, but we will learn them. So I want you to go to bright space, because this is something I will do a lot, and go to the content area. Okay, because this will make it easier for you to work with me. Go to the content area, and there is a module called worksheet. Please let me know if you found it, because I'm sure I put it last night. Did you find it? Tell me yes.
Yeah.
Yes, everyone? Click on it, and you are going to be working on this worksheet together today, all right, to fortify your understanding of a function and to help you with the problem. Okay, so pick up the worksheet, and I'm going to read the problem so we can understand it very well. But since it's in front of you, so in case you cannot read carefully from here, I know that you guys have it in front of you. So first we have to understand what the problem is about. It's about function, and then we're going to answer some of the questions. All right, so I read it very slowly. 100 people are in a line. So try to have an image in your head, what's going on. And let A be the set of integers from 1 to 100. It means A is 1, 2, 3 to 100, a bunch of numbers. So I have people in line. So I'm going to draw those people right here. Okay. All right, so I have those bunch of people in line, 100 of them. So that's the best I can do for people. That's how much my art goes. So etc., etc. So I have a bunch of people. So this one is first in line, second in line, third in line, and that's 100 in line. So people are in line. And then I have a function. I have a rule that to each number m in A, so A is those numbers, 1, 2, 3, 4. That's A. 1 represent the first person in line, 2, and so on. And F is the function that assigns to each number in A the first name of the person who is the mth person in the line. Let's see what does it mean. means f is the following function. That's so a is 1, 2, 3. Assigns to 1 the name of person. It is assigned to 1 the name of first person in line. That's really what the rule. That's what f is doing. To 2, the name of the second person in line. Second person in line. So imagine you have a bunch of people in line waiting to buy ticket to go to a concert. Okay, and you number them, 1, 2, 3, or 100. And you have the following function. To the first person in line, it assigns its name. Second person in line, assign its name. So this is really my function f. Third person in line, the same thing. So that's really my rule. 100 person in line. So that's really the rule that I have. All right. Let us say John is the 20th person in the line. So John is the 20th. So let us assume this is 20. And so that's number 20. And John is here. Okay. And Sally is somewhere standing near the middle. So somewhere around here, the 50th spot is where Sally is. Answer the following questions, explain completely. Okay. So let us see, understand what does it mean. Question number A, what does f of 1 tell you? So when I evaluate f of 1, so the first question is to try to understand what the function is. So what does f of 1 tell you? Back to you.
F of 1 would tell us the name of the very first person in the line then.
Right. So the input here, let's see what the input values here. The inputs are 1, 2, 3, 4, 5 to 100. Those are my input values. What are my output value? What am I assigning to them? My output value are the name of people. These are my output value. So the input of 1, the output is the name of the first person in line. So what does f of 1 tell you? So f of 1 is f of 1, that's the output that corresponds to the input of 1, or what f assigned to 1. So f of 1 is the name of the first person in line. It's a function. There cannot be 2 persons. I mean, the first person in line have exactly 1 name. So that is actually a function. We don't have an issue with that. Now, we keep going. What does f of 100 tell you? So that's really the picture. And I think now the question should be easier. So what does f of 100 tell you?
The name of the 100th person in line?
Yeah, or the last person if you want. Yeah. So F100 is the name of the 100th person in line or the last person. Or if you want, the last person. So once we understand the assignment, we understand the function. That's really the idea. Okay, remember, f of 100 is the output. F of 100 is the output. Now, what is f of 20?
John.
F of 20 is equal to John in this particular scenario. Okay, John is the output. Now, let us say Sally, they didn't tell us exactly where she is. She is somewhere around the middle, around the 50th in line. So let us say Sally is the nth person in line. What does f of n plus 2 tell you?
It would be the name of the person 2 ahead of Sally.
2 ahead. You're half correct. Anybody?
2 behind Sally?
2 behind. 2 behind Sally. Why 2 behind Sally?
Because since it's going in 1, 2, 3, 4 order.
Right. So n plus 2 is going to be after Sally.
Yeah.
So what is f of n plus 2? So let us say Sally, let's pick numbers for n, and then I give you the answer without really n. Let us say Sally is in the, let's make the scenario. Suppose Sally is the 60th person in line. Let us suppose, you don't have to write this, you write the exact, but let us give n a number. It means that n here is 60. Okay? What is f of n plus 2? F of n plus 2, in my scenario, it means f of 62. Am I right? Am I making sense? So what is f of 62 in the picture? So if these are the people, in the 60th place, let us assume here 60, it's Sally in the 60th place. So if I add 2, so that's f of 62. It means it's the name of the person, which is 2 places behind Sally in the line, or 2 spots behind Sally in the line. So if Sally is here, f of n plus 2 is somebody who is 2 spots behind Sally in the line. So f of n plus 2 tells you the name. So f of n plus 2 is an output. So it's the name. So it's the name of the person that is 2 spots behind Sally in the line. Okay. So the whole problem is to start understand, try to make sense out of the rule. What does the rule does? Because a function is a rule. What does it do? What does it do to every input? What does it? That's really the idea. Now again, now suppose Sally is the nth person in the line. What does f of n minus 2 tell you?
F of n minus 2 tells you the name of the person 2 spots ahead of Sally.
Right, name of the person that is 2 spots ahead of Sally. Okay. So this is a function, and it's different than, as I said, it's not, of course, we're going to work with function that deals with formulas and stuff, but this is those type of problem to help us, solidify the idea of a function, that it is a rule that is assigned to every input value exactly one output value. That's really the idea. All right. Along the same line, we're going to keep working with function. And we're going to start working with number 2. And I will read it, and then I'll give you a minute to interact with it. But this time I won't explain anything. I want you to try to understand it, and then we talk about it. 2, let A be the set of all US citizens in the United States, sorry. And F is a function that assigns to each citizen, so it assigns to each citizen the number of letters in their first name. For each item below, indicate the type of object that the item is. For example, is the item a number? Is the item a name? Is the item person? So the idea is to understand the assignment. Okay, I'll give you a minute to read the problem again and try to understand what is F doing to an input. And then we discuss the problem. So please read it, because you will have to read it twice, and then ask yourself, what is F doing? What does F, so what are the input values? What's F doing to the input? right? Okay, I'm gonna pick one of you and ask a questions. Before we answer part A, my question is to see if we understand the function. So let me pick Daniel. Daniel C, I guess, the last name. All right. What does F do? Can you tell me in words? Please, I want you to work with me. That's the only way we're gonna learn in this class. So what are the input values here? What are the output? And what's the F doing? Okay, Ricky, that's okay. Don't worry, Daniel, just listen to us. Make sure to stay with us. Ricky, do you think you're ready? All right, Danielle, number of letter in their first name. Okay, Danielle is giving us an answer, so I will stick to Danielle. So let's see what F did. What are the input here? The inputs are what in this problem? F is assigned to each citizen. So the input here to each citizen. So these are the input value. We're assigning to each citizen. So that's how I see the function. So every citizen, these are my input value, is going to assign something, the output. What's going to assign? The number of letters in their first name. So my function, that's my function F, to every citizen is going to assign the number of letters in their first name. Okay, so citizen, it means any citizen. So it associates the number of letters. So for example, so even before we answer the question, so the input here are the US citizen. We have millions of them. So the input, we have a lot of elements. The output are a bunch of names. So John, Norma, Bill, and so on and so forth. These are the output values. So suppose I tell you what is F of, let me pick a name. Okay, mine is the easiest. I am a US citizen, as I said, despite my accent. So what is F of Norma Elias? Norma Elias, that's the input. And what is F of Norma? Quickly.
5.
5. It's the number of letters in her first name. 1, 2, 3, 4, 5. F of Norma is equal to 5. That's really what the function is doing. It's taking the input, which is the US citizen, the output that we denote by F of the input is equal to 5. So first we understand what the function is and we take example to understand it. Now with this in mind, I go back to my question. What type of object is F of C? Now what does C here represent? The C here is a variable. So C is a symbol, if you want, for a US citizen. Because we cannot always use particular value. We have to use variable because I want to say, okay, in general. So that's what C. So this C here is the symbol for US citizen. The question is F of C. What type of object is it? Is it a number? Is it a name? Is it a person? All right, who would like to answer the question?
F of C is a person, like their name.
And do you agree with him? Do you agree with him? Let us think one more time. What does F do? One more time. F does what? It is assigned to US citizen what?
A number based on their first name.
The number of letters in their first name. Okay? So if I input Norma, what's my function should output? Quickly.
5.
5. If I input, for example, Madison, that's another US citizen, what will be my output?
7.
7.
7.
Okay, that's really what my output is. And I can keep going forever, right? I can keep going forever. If I input, let us say, Ricky, what's going to be my output? Okay, Ricky has 5 letters in his name. That's really the output. Now, suppose I call C a symbol for Ricky, Norma, Madison, Michelle, blah, blah, blah. C is a symbol for every US citizen. So that's a symbol. What is F going to associate to C? It's going to associate the number of letters in the first name of C. Now I ask my question again. What type of object is f of c?
It's a number.
It's a name. Yeah.
Is it a name? What is the name? What is the name in this picture? C is the name of the citizen. That's the input. F of c is the output that corresponds to C. So what type of object is the output? It's the number of letters in the first name. So F of C, which is the output that corresponds to the letter C, in this case, is nothing more than a number. It's not the name. What's the name? C is the name, the input. F of C, that's the output that corresponds to C. This one is a number, is not a symbol, is not a name. I stop. Is it making any sense?
Yeah.
You understand why it's not a name? Why f of c is not a name? Who can articulate it for me one more time?
F of c itself is a whole value by itself, so it would be the number that results from the output.
Yeah.
Even though c is the name.
Because c is what? What goes inside the parenthesis is my input value. It means the thing, the object I assign something to. What am I assigning something to? I'm assigning to the US citizen something. Those are my input. So what's go between the parentheses are what I assign to, which are the US citizen. F of C is what is it I am assigning to C. That's the output. What I am assigning to C is the number of letters. So what type of object is f of c? F of c is a number. What number? Is actually the number of letters in the first name of C. C is a symbol here of the US citizen. That's what we have to use symbols, because I cannot tell you, okay, I cannot always give you a value for C. It's impossible. So we use symbols to represent any US citizen. So f of c is the number. Which number? It's a very particular number. It's the number of letter in the first name of C. Right. Let me take the second question. It's the second page. Right, sorry, it's right there. Okay. Again, I want you to read. It's a little bit confusing, but not that much. If you understand the function, we can understand how to answer those. If f of c equal d, what type of object is C? I give you a minute. It's the same problem. So it's the same thing. F is again this function that does the following. It takes a US citizen, these are for input, and assign the number of letters in the first name. That's really what my function. So the input are names of US citizen. The output is the number of letters in first name. So if f of c equal to d, what object is C? A number, a letter, a name? That's my question. Right? Anybody? I have answers.
C alone should be a name.
C alone should be a name. Absolutely, because that's the input value. So C is a name of US citizen. That's what C is. It's the input value. It's the name of the US citizen. What about D? What about D in this picture?
Number of letters in the name.
Right, it's the number of letters. That's the output values because D is F of C. It means D represents an output value because it's F of C. So D is the number of letters in the name C. Okay, so C, what goes inside is the input or the thing we assign something to. We're assigning to you as citizen. F of C is what we assign to C. Right? Okay. My last example is something that easier for you. So it's a numeric example. First, any questions before I move on? Please ask questions. All right, very good. Now, the last one, I think it's easier because it's numbers. So let A and B be the set of all numbers, bunch of numbers. And F is the function that to each element X in A, it means to each number, every possible number, it assigns -3 times the number plus 2. So another way of writing this is that F of any number is -3 times the number plus 2. Oh, I should have left a space here, my apology. Determine the following. So this is my function this time. So this function now, my function is from numbers to numbers, so no US citizen or anything. So that's an easier scenario. And my F does the following. So for every number, it's going to associate -3 times the number. That's really what it does, plus 2. That's really how I see my function. That's the kind of association. Now, to write this in a more symbolic way, it means it takes X, whatever you give it, and it spits out -3 times X plus 2. Or in more function notation, we write that what F does to X is -3X plus 2. Okay, so this is really the picture. So that's a function. You give it a number, it gives associate something, assign something to it. It's -3 times the number plus 2. Now determine the following. I forgot to leave a space here, so I need to write right there. What is F of 4? So this is the rule in general. What does F do to 4? Okay.
It would be -10.
-3. Yes. Plus 2. So -3 times the number, that's what F does, plus 2, that's what F does. So this gives me -12 plus 2, which is -10. Now, what does F do to -6?
You get +20.
That's what you got. So I plus 2 times the number plus 2. Equal 20. That's how the function behaves. Now, what is F of 1/3? Remember, a number could be anything. All right, this is equal to. Did you guys do it? Okay. It's -3 times the number, so that's multiplied by the number, plus 2. Okay, so it's -3 multiplied. Now, -3 times 1/3 is basically -1, am I right? Plus 2, which is equal to 1. Okay, so 3 times 1/3, that's really what we're using, is of course 1. Okay, so that's how F acts. Now question 2, and then the rest you guys will discuss it next time. But part B, I would like to do B and C. B. And this one I can do it on the papers because I left room for that. If T is any number, determine what F of T is. So what is F of T? So we know what F does. F does the following. You give it something, whatever you give it, a number, it associates to it -3 times whatever you give it at 2. That's really what it does. That's really what my F does. So what is F of T?
-3t plus 2.
-3t plus 2. Nothing to be scared of. -3t plus 2. That's what F does. If you give it anything, it's -3 what you give it plus 2. So if you give it a t, okay, all right, in general, so we're trying, of course, we have to use symbolism. It give it, that's what it does to it. Okay. Last question, and then I stop right there. C. I want you to read C very carefully. Find a number C. We have to find a number such that F of C is -24. What are they asking us about? What are they asking us about here?
They're asking us to find a number and put for C that would multiply and add with -3 and +2. That would result in -24.
So -24 here, is this an input value or an output value?
An output.
That's an output. I want all of you to be able. So here, this is a problem where they are giving me the output. It's right there. And the question is, what should you put in input that take you to an output of -24? All right, so -24, that's an output. And now the question is, we're going to find the input such that F of C is -24. So what is the input that brings up an output of -24? Now, we can guess, but guessing is not. It means I want to find the C such that -3 times C plus 2 equal to -24. So my question is, what is the C here? So that I will have that equal -24. What should I put here for C? So we're not to solve for C. We're going to set and solve for C. All right, let us remember how we solve this equation. I'm sure all of us. First, we have to isolate -3t. To do that, I need to subtract 2 from both sides. So we isolate it by subtracting 2 from both sides. -2. All right. So this will give me that -3c is -26. So I isolate my unknown. And finally here I divide. Now I want to isolate the c. I divide by -3. And then I will get c equal -26 over -3. Now minus over minus, that's a plus. I will get 26 over 3. And that's the input. So basically, if I put in 26 over 3 and I let F act on it, F should give me -24. So that's the one I really needed in this picture. Okay. I think time is up. Okay, that's it for today. I hope you have a good semester. The practice problems are on Brightspace. So you go to content area, you go to practice problem, then they will have practice problem for 114. Please make sure to do them for Thursday. Please make sure to do them. Write them up. When we get to class on Thursday, the first thing you will do is to tell me, I didn't know how to do that. I didn't understand that. And so on. We discuss them and then we proceed. Okay, best of luck for this semester. Bye-bye, guys.